Micro-inverters versus string inverters. Welcome to this presentation comparing micro-inverters and string inverters in solar panel systems. We'll explore how each system works, their advantages and disadvantages, and how to select the best option for maximizing energy generation. Introduction to solar inverters. Inverters are the heart of every solar system. They convert the direct current, or DC, produced by solar panels into alternating current, or AC, that powers homes and businesses. Without them, solar energy isn't usable in most electrical systems. String inverters. Overview. String inverters connect several panels in a single series, or string. This design is simple and affordable but comes with one weakness: if one panel's output drops, it can affect the performance of the whole string. Microinverters. Overview. Microinverters are small devices attached to each solar panel. They convert DC to AC right at the source. This allows each panel to operate independently, which is ideal for installations with shading or different panel orientations. System architecture comparison. In a string inverter system, many panels send power to a central inverter. In a microinverter setup, each panel works individually. This decentralized approach enhances performance consistency and allows for better system monitoring. Performance and efficiency. Microinverters tend to maintain higher energy output when some panels are shaded or dirty. String inverters, on the other hand, can lose efficiency if just one panel is obstructed. In uniform conditions, however, both perform comparably. Installation and maintenance. String inverters are easier and faster to install since there's only one central inverter. Microinverters require more setup time and wiring, but they make it easy to monitor each panel and replace faulty ones individually. Reliability and lifespan. Microinverters usually last around 20 to 25 years because they handle smaller loads and distribute work evenly. String inverters typically last 10 to 15 years and may need replacement once during the system's lifetime. Cost analysis. String inverters have a lower upfront cost, making them popular for large installations. Microinverters are more expensive initially but can deliver better performance and a higher return on investment over time. Best use cases. Use string inverters for large, evenly sunlit roofs where simplicity matters. Choose microinverters for shaded, irregular, or smaller setups where efficiency and flexibility are key. Summary and takeaways. Microinverters offer higher efficiency, reliability, and monitoring capabilities, while string inverters remain cost-effective and proven. The best choice depends on your site, budget, and energy goals. Thank you. Thanks for joining this comparison of microinverters versus string inverters. If you found this useful, consider liking, sharing, or subscribing for more clean energy insights.